All right, let's pick up where we left off in the previous video on DynamoDB. And let me share my screen. So we had just created a very unique, non-normalized table that has all kinds of interesting features in it. Is specifically that we have uh, forklifts, buildings, stores, employees, and even cash registers that are all included in the same table. And for some use cases, this is a good thing and recommended by AWS themselves. All right. Having created a bunch of records, the next thing I want to do is show how to query this very unique setup where we have like a W pound for anything that relates to a warehouse in the primary partition key. We have an S pound for anything related to a retail storefront entity, and the sort key with its Fs or Rs or Ms represents things like, is this a forklift? Is this a cash register? Is this a manager? So let us go up to query and let's search for all the records that are related to store number 1234. So I'll go S pound 123. I did that wrong. S pound 1234. And we won't do anything with the sort key. And there we go. So we don't have any of the warehouse records, but we have everything that relates to this particular store. So imagine if you had 33,000 retail locations, you could enter in just one of them and see all kinds of interesting things related to that. You could see the employees, you can see the cash registers, you could see information related to the building itself. And if we wanted to know just about the building itself, we would enter in S pound 1234 in the sort key. And that gives us just that building information back. All right. Another thing we can do is search for specific things. So imagine that we want to know just the managers that work there. We could say, because we used a string, we could say, show me anything at that location that begins with M pound. So we don't care which one, just any of them. And so this structure that we've created, or this design, allows us to very easily query for everybody of a certain type from the store. Now let's look at our sort key options. So we can have things that are equal to, less than, greater than, between, and begins with. And so we just did begins with. So some of these are more applicable to numbers, and some of them are more applicable to strings. And just for fun, I'll say equal to M2. Let's see if that works. Yep, that one worked just fine. All right, let's see. We could also do, how about this one? Greater than M2. And if we run it, oh, interesting. It gave us a whole bunch of different letters. So we didn't really like how that turned out, how interpreted it. Okay, and I have a list of things to try. I say try a sort key greater than M1. So this is in my little tutorial document, and see what comes back. I say, how about something less than M2, just for giggles. And that's what we get for that. And then I recommend doing a forklift query. So a little bit more generic, like how would you query for forklifts? Well, I guess the first thing we're going to need is I'm going to go back to scan for a second. Warehouse 3456. All right, so we're going to use our partition key warehouse 3, 4, 5, 6. And then maybe I'll start off with begins with F pound. And so that gives me all of the forklifts. And so the thing says, how about do a query for forklifts that are purchased after, and then there's a date there, 6/9/2019. So what I can do is I can, in addition to saying, just give me the forklifts, I can add an additional filter, and the attribute is going to be purchase date, and that is going to be a number, and I'll say greater than, and type in this date. So I've got 2 layers of filtering, and I do run, and I get back that. All right. So as we're doing that again, it only takes 0.5 read capacity units. If I do a scan, it requires more resources. Well, it appears that that is all I needed to finish this out. So I'm sorry that this particular one is so short. Let me just pause for a second and just think about if any remaining thoughts that I might have. So my concluding thoughts would just be understand that this approach that was used here, and not only this one, but just more generically using a NoSQL database, is applicable to all kinds of different applications. You could have gaming platforms, shopping carts, inventory tracking, customer profiles, content metadata, caches, bank user transactions. You could use it as part of fraud detection, digital right management. There's all kinds of different ways that you could use these types of tables with their interesting adaptability. Anyway, so there's lots of different ways that you can use them, and it requires a lot of practice to come up with good, I guess it is schemaless, but at the same time, we're conceptually creating a schema. But creating those good schemas is a result of practice, and so that's what you'll have to do. All right, let's go ahead and go over to our list of tables and delete the things that we have created recently. We're going to select building, goodbye building. And then we also had sensor readings 1 and 2. We'll delete those. We will leave this selected where it says delete the CloudWatch alarms. And we are done. So I hope that you have an absolutely great day. Bye.